Hey guys, so today we'll be working on some more questions of the form integral dx upon px square plus qx plus r. Now with some variation in it. We have been doing this kind of integration in the previous couple of lectures. Now I'm giving you an example where we have a square root. So let's find the integral of dx upon square root of 5x square minus 2x. The procedure will be quite similar. Let's see what we can do here. So we have, this is your I. So I is equal to, what I can do is, I can take root 5 common. So what I'm going to do is, in the square root, I'm going to take 5 common. So hence I'll be left with x square minus 2 by 5x. Okay? 2 by 5x. Now that means that what I can do is I can take out this 1 upon root 5. So I can keep 1 upon root 5 outside the integral dx upon, this is square root of x square minus 2 by x5. Can you see that you can create a square minus b square here? You can create whole square here. So what I'm going to do is I'm going to add and subtract something here. And that is I'm going to add and subtract 1 by 5 whole square. So this gives me that I becomes 1 upon root 5 integral dx upon square root of x minus 1 by root 5 whole square minus 1 upon 5 whole square. So this essentially works like the form integral of dx upon square root of x square minus a square. So what we can do is we can take x minus 5. We can take x minus 5, 1 by 5, x minus 1 by 5 could be taken as t and dx becomes dt. So I can rewrite my integral as 1 upon root 5 1 upon root 5 dt upon t square minus 1 by 5 whole square. And we know what this integral is. This integral, we have already proved that it will be log of mod t plus square root of t square. Okay, I forgot to write the square root here. Minus 1 by 5 whole square plus c, right? So this is what you will get. Now you can substitute. Just substitute 1 upon root 5 log mod x minus 1 by 5 plus square root of x square minus 2 by 5x plus c. So this is what will be the answer to this problem. So what have we done? What we have figured out here is the integral dx upon the form of square root of, ax square plus bx plus c, right? So that's what we've done here. Now let's take some more examples, but this time of a different kind. So we've done this form. Let's change the form a little bit. So let's have some more cases to look at now. Let's take the case of find integral of the type integral px plus q holding upon ax square plus bx plus c dx. So this time numerator is not just 1, it is px plus q. Then what will you do? Now this will take some trick. This will take some trick into it. Let's see what that trick is. So, what you can do is you can find real numbers a and b, real numbers a and b, such that px plus q behaves like a times d by dx of what you have in the denominator, that is ax square plus bx plus c plus b. So px plus q actually looks like a times d by dx of what you have in the denominator plus b. Or in other words, what you have in the denominator, when you will take the derivative, you will get 2ax plus b plus b. So px plus q looks like this. Now, to determine a and b, what you need to do, you need to equate the coefficient of like powers, right? These are like polynomials, right? So to find a and b, what we got to do, we got to equate the two sides. We got to equate the two sides and we will solve. Now, to understand this, let's take up a question. Let's take up a question in order to understand this. So suppose we have integral x plus 2 holding upon 2x square plus 6x plus 5 dx. Now, how to solve it? You got to put x plus 2 as a times 4x, or let me make you comfortable, d by dx of 2x square plus 6x plus 5 plus b. In other words, what we are doing, we are equating it to a times 4x plus 6 plus b. That means, what are we saying? We're saying that the coefficient with x on the left hand side is 1. So 1 is equal to 4a, which implies a is equal to 1 by 4, right? And the constant term is 2 on the left hand side, which means 6a plus b is equal to 2. If 6a plus b is equal to 2, that implies 2 is equal to 6 into 1 by 4 plus b, or in other words, 2 minus 3 by 2 is equal to b, which implies that b is equal to actually half. B will be equal to half, right? So this means my integral will look like, this means the integral looks like, integral I looks like in place of px plus q, you can write down a, which is 1 by 4 into d by dx, that is 4x plus 6 plus half upon square root of, no, we didn't have any square root here, sorry. This was not the square root case. Square root case will also come, don't worry. So upon 2x square plus 6x plus 5 dx, right? Now what you can do is just simplify this. Simplify in the sense in terms of you can break it up. So this will become integral 1 upon 4. So this will become 1 upon 4. 1 upon 4, 4x plus 6, whole thing upon 2x square plus 6x plus 5 plus half, and dx, the integral, half dx upon 2x square plus 6x plus 5. So what we've done is we've broken it up, and this is one integral and this is another integral, say I2. So what will be I1? I1 is integral 1 by 4 outside 4x plus 6 holding upon 2x square plus 6x plus 5 dx, which is equal to, now how to solve it? What will you do? If you have this case, how do we solve it? We've just done it in the previous case, right? So what we will do, we will take 2x square plus 6x plus 5 as some t, and 4x plus 6 dx becomes dt. Hence, what do you get here? Hence, this is equal to 1 upon 4 integral dt upon t. In other words, it's nothing but 1 upon 4 log of mod t, or log of mod. I can directly put in 2x square plus 6x plus 5 plus a constant, right? And then you have the second part, I2. Then you have the second part, I2. Let's talk about I2 now. So I2 is equal to half dx upon 2x square plus 6x plus 5. Now, this one is where you have to create whole squares, right? This one is where you will be creating whole squares. So this will be equal to, half stays outside, integral. Let's take 2 common. So I will take half here. This becomes dx upon x square plus 3x plus 5 by 2, right? And hence what this will become, 1 upon 4 and integral dx x square plus 3x, since you have 3x here. So that means what I'm going to do is I will add and subtract 3 by 2 whole square. So plus 3 by 2 whole square minus 3 by 2 whole square plus 5 by 2. So this will become 1 upon 4 . So your denominator will become x plus 3 by 2 whole square plus 1 by 4 is left. So I can write it down as 1 upon 2 whole square, right? Now what you can do is you can put x plus 3 by 2 as t, and dx is equal to dt. And this whole expression will look like 1 upon 4 outside and dt upon t square plus half square. Hence the solution, we already know what a solution is for these kind of integrals. So the solution will become, you will get something in tan inverse, yeah? So this will be 1 upon 4 is outside. And since your a square, a is half. So what's going to happen is you will have 1 upon a tan inverse t by a. So t by a. A is half. So t by a plus, say, let's call it c dash. So this will give you 1 upon 2 tan inverse 2t plus c dash. Now you can replace what c is, what t is. So half tan inverse x plus 3 by 2 plus c dash, right? So this is what you will get here. So this is what you will get here. What we have been looking for is I1 plus I2. So I1 plus I2 will give you I1 plus I2 will give you 1 by 4 log mod 2x square plus 6x plus 5 plus I2 gives you half tan inverse x plus 3 by 2 and plus the constant. So you can add both the constants and you have some c, some constant. Okay, so that's how it's going to be. Next question. In order to understand this even better, let's take another question. So let's take integral of x plus 3 upon, this time I'm going to give a twist to the question with a square root. So square root 5 minus 4x minus x squared dx. Okay. So again, the form is sort of where you have px plus q in the numerator. So the working will be exactly the same. You will put x plus 3 as equal to a times d by dx of 5 minus 4x minus x squared plus b. That is, it's a times minus 4 minus 2x plus b. So comparing the coefficients of like terms, so 1 is equal to minus 4a, minus 2a, sorry, minus 2a, which implies that a is equal to minus half, and 3 is equal to the constant is minus 4a plus b. This implies 3 is equal to minus 4 into minus half plus b. So which implies that b is equal to 1. Which implies that b is equal to 1. So you have your a, you have b as well. Now let's put it up and solve. So that means integral x plus 3 whole thing upon square root of 5 minus 4x minus x square dx is equal to minus half integral x upon square root of 5 minus 4x minus minus 4 so this will be minus 4 minus 2x dx upon square root of 5 minus 4x minus x square plus b is 1, so just the integral plus b, so just the integral dx upon square root of 5 minus 4x minus x square. Okay. So this is your I1. The first integral we can take as I1. This is I1 and this is I2. So let's work with I1 first. So I1 is minus half, or let me just keep minus 1 outside. So let's just take the integral I1. So it's integral minus 4 minus 2x dx upon square root of 5 minus 4x minus x square. Now clearly we can take 5 minus 4x minus x square as t. So minus 4 minus 2x dx is equal to dt. And this whole thing turns into an I1 turns into integral dt upon square root of t. Right? So now let's solve it. This will be nothing but 2 times root t plus c1, which basically means it's 2 times square root of 5 minus 4x minus x square plus c1, right? And similarly, I2. Let's now look at I2. I2 is integral dx upon square root of 5 minus 4x minus x square. So what we can do here? So you can, again, what do we have to do? We have to create whole squares here. So this will become dx upon, what I've done is I've taken the minus sign common here and I've added and subtracted 4 because that's what is required. And then you will utilize plus 4 and minus 4 will come outside, but minus minus is plus. So this will give you 9 minus x plus 2 whole square. So essentially what do you have? You have t dx upon 3 square minus x plus 2 square, wherein what you can do is put you can now put x plus 2 as t, so dx equals to dt. Put x plus 2 as t, so dx is equal to dt. And this integral turns into dt upon 3 square minus t square. Now, you know, when you have a square minus x square, what is the integral? Integral will be in terms of sine. So this will give you sine inverse t by 3 plus, say, c2. Now you can substitute back. It is sine inverse x plus 2 by 3 plus c2. Now combine and get the answer. So I1 plus I2, not I1 plus I2, but it is minus half times I1 plus I2. It will give you minus half into 2, 5 minus 4x minus x square plus sine inverse x plus 2 by 3 plus some constant. So this would be the final answer, 2 to cancel. So you have minus square root. It's starting with this one. Okay.